Let's imagine that your model had poor accuracy and you really don't care about interpretability. There are methods to improve accuracy at the cost of interpretability, and one of those methods is called stacking. Stacking is where you train different models, let's say a support vector machine, a neural net, and a random forest, all in the same data set. You can then combine them into what I'm calling the supermodel. This supermodel can be any model like a random forest or a support vector machine. The most common one is a general linear model because effectively it becomes a voting system where each model gets a vote on which group the observation is part of. Whichever group receives the most votes from the models is the decision that the supermodel will make. Before running this, I must warn you that it takes a lot of memory in order to run. My laptop was having some issues with it, so I had to use my work computer in order to make it work. So I encourage you to proceed with caution when running this. The setup is pretty similar to training just one model. We'll be using the caret ensemble package to do many of the following commands. We will first define our cross-validation like we've done before. Also, we're going to define the list of algorithms or models we'll be using. We'll run each model using the caret list command. Now that that's done, a new cross-validation needs to be defined for the supermodel. It's very important this is a new cross-validation. Then we can run the stack using the caret stack command. We can plot the models' performances and compare them. Ideally, you want the models that don't make the same decisions, because then it defeats the purpose of the stack if they all vote the same way. It's best to have uncorrelated models in the stack, and finding them is an art that I'm personally not very good at, as you can see. Unfortunately, the stack didn't improve accuracy. There are some easy adjustments you can do to make it better, but I'll leave that for you to figure out.